This video is all about naming alcohols, by which we mean, of course, the rules for the systematic naming of organic molecules containing alcohol functional groups. By the end of the video, you should be able to give the systematic name of a molecule with an alcohol functional group if shown the structure, and you should also be able to use a systematic name to draw the structure of an organic molecule with an alcohol functional group. To make sense of this video, you really need to be familiar already with the systematic naming rules for alkanes, and we'll see that the rules for alcohols really just build on the alkane rules. But one key difference is that whereas alkane names end "ane", like methane, ethane, propane, alcohol names will end "ol". We'll look at an example and use that to explore the rules. So here's a molecule drawn both skeletally and shortened structurally. It's the same molecule. And the name of this is hexane 2-ol. So let's unpack that and see how the naming works. We've got hex at the start, and that's exactly the same as the principles you've learnt for the alkanes, that 6 carbons in the longest chain in the molecule is hex. We've got the AN after it as if similar to it would be for the alkane, but instead of just ending ANE, then we've got a difference there. And so we've got the ol ending at the very end, and that shows clearly the presence of an alcohol group. And the number 2 shows the position of the alcohol group along the chain. So hexane 2-ol is a 6-carbon chain with an alcohol group, OH group, attached to carbon 2 of the chain. So if you want to think about it this way, to name an alcohol, you chop the E off the end of the alkane name for the molecule if the alcohol group wasn't there, and then you put a number to show the position of the alcohol group, and then OL to show that it's an alcohol. Having introduced these rules, we need to mention a couple of exceptions which don't quite fit, and that's because you don't include a number in their name. Let's look at the 2 alcohols involved. The first is this 1-carbon alcohol, its name is methanol, and the second one is the 2-carbon alcohol, ethanol. So in both cases there's no number between the an and the ol, and that's because it doesn't matter where you put the OH on the structure, the molecule would be identical. It would just be the same molecule spun round, flipped over, upside down, or whatever. So we only need a number. In fact, we can only put a number in a name if the number of carbons means that there's more than one possibility for where the OH group could be. And so we reach that when we get to 3 carbons. You can see the 2 structures here. There's a choice. Is the OH on the end carbon, or is it on the middle carbon? Now that means we can't just call a 3-carbon alcohol propanol, because you can't have one name with 2 possible different structures that come from it. So in this case we have to start putting the numbers in now. Propan 1-ol if the OH is on the end carbon, and propan 2-ol if it's on the middle carbon. Our discussions so far have referred to molecules with only one alcohol group, but there's nothing to stop there being more than one alcohol group attached to a molecule, like the example shown here. Now, the rule for naming molecules with more than one alcohol group is that you use a multiplier in front of the ol, di if there's 2 alcohol groups, and it would be tri if there was 3 alcohol groups. So the same things that we've already used when doing branches with the alkanes. We'll need to have a number for every alcohol group, so here with 2 alcohol groups as well as the diol at the end, we'll need 2 numbers, one to show the position of each of the 2 alcohol groups. If we had a triol with 3 alcohol groups, we'd need 3 numbers in front of the triol, and so on. The name in this case comes out as pentane 1,3-diol, and so with the numbers shown on the carbon chain, you can see that we're counting from the right-hand end of the chain, and that's following the same principle you'd have seen with the alkane, the branched alkanes, that you start numbering from whichever end of the chain gives you the smallest numbers for the things that are attached to the chain. Here's another example, this time written in the shortened structural formula format for an alcohol with more than one OH group attached. Why don't you pause the video, have a good look, and see if you can work out what its name would be. And you should have come up with that it's got 5 carbons, so it's a pentane molecule, and then with the 3 alcohol groups it's a triol at the end, and we need 3 numbers. 2 of them are on a carbon 1, counting from the left end of the chain this time gives us the lowest numbers, and 1 of them is on carbon 3, so pentane 1,1,3 triol. The more observant amongst you will have noticed that an E has snuck back into the name there. Instead of pentan 1,3-diol or pentan 1,1,3-triol, it's pentane. And the convention is, for some unknown reason, that once you've got more than 1 alcohol group, you no longer lose the E of the alkane name when you're writing the name. The final layer of complexity that we need to consider is when we have branches on the carbon chain as well as alcohol groups. Now, you should already know how to name branched alkanes, and the same rules apply here with one key difference, and that is when it comes to the numbering. We number the alcohol group first using the rule that we take the lowest number possible. So we count from whichever end of the chain gives us the lowest number. So ignoring the branches, just looking at the alcohol group, which end of the chain do we number from? It's the end that will give us the lowest number for the alcohol group or groups. So looking at this molecule, and we can see we need to count from the right hand end of the chain. It's a 6 carbon chain, and so it's hexane 2-ol. And then we can think about the branches keeping the numbering the same. So since we've started numbering from the right, we have to keep numbering from the right. We can't suddenly start numbering from the other end as well. And that means in this case that the 2 methyl branches sticking off the 6 carbon chain are both on carbon 5. And so the full name of this molecule is 5,5-dimethyl hexane 2-ol. No doubt by now you're dying to have a go at yourself. So some little practice examples coming up here. For the first one, come up with the systematic name for this alcohol drawn in the skeletal formula format. And you should have come up with the name butan 2-ol. It's a 4 carbon chain. That would give us butane if it was just an alkane, so we chop the E off, put the ol ending on, and we have to have the number 2 before the ol ending to show the alcohol is on carbon 2. If you said it was on carbon 3, that means you were counting from the left, when actually you should have been counting from the right. So remember, you count from whichever end of the chain gives you the lowest number for the alcohol group. Next example is a shortened structural formula. See if you can figure this one out and name it using the systematic naming rules. So the name comes out as 4-methyl pentan 1-ol. The CH3 in brackets halfway along means that there's a methyl group attached to one of the carbons, and the OH is right at the far end there. So that means we're going to have to start numbering from that right hand end as carbon 1 with the alcohol group. There's 5 carbons in the chain, so pentan 1-ol, and then numbering from the right backwards. The methyl group is attached to the carbon written to the left of it, and so that's carbon 4, so 4-methyl pentan 1-ol. Another challenge, see if you can draw 3-ethyl hexane 1,6-diol. If I was you, I would do it in the skeletal format to save yourself a bunch of time. And it should come out looking like this. So a zigzag for 6 carbons with an OH group at each end, and then an ethyl group coming off a carbon, which is carbon 3. It doesn't matter which end you come from, actually. You could count from the left or the right when you're drawing. Just check carefully that you've put the right number of carbons into the zigzag. People quite often make the mistake of doing a sort of 6 carbon chain and then just writing OH at each end of it, which then suggests that there isn't a carbon at the end. So you actually need to draw an extra line out to each of the OH groups. And so you need to just check that you've done the zigzag properly.